Mark P. Otten back with you. All right, welcome to your SPSS data screening overview. We're going to get a bunch of statistics and a couple of graphs here. It's going to be very exciting. Okay, so this is real data that I pulled from, it's like a subset of one of our samples of CSUN students. Two items that we asked them, well, we asked them some other stuff too, but I pulled these two out. The first one is how physically fit do you think you are currently? And the second one is, are you unable to relax? And that second one is from a larger anxiety scale. So like if you're unable to relax, that's a symptom of trait anxiety. Like in general, over time, you're unable to release the anxiety. So for example, so the first one is on a scale of 1 to 10. The first person there scored a 9 out of 10 on the fitness. They actually won the contest there. Nobody said 10 out of 10, but this person was the highest at 9 out of 10. And then they said 1, and the relaxation scale is only 1 to 4. So this person is not unable to relax. They are able to relax more than most, and they're also more physically fit than most, which fits the theory that if you're engaging in fitness activities, you're less likely to be anxious. So maybe not everyone was like that. The idea is that we screen this out for missing data and try to figure out if these variables, let's say, are ready to be analyzed together. Maybe there's a correlation coming up for fitness and anxiety. So let's get this data ready for such a thing. To do that, we're going to go to Analyze and Descriptive Statistics and Frequencies, and we're going to get a bunch of data here in one swoop. SPSS is great. Okay, so I'm going to pretend like I haven't done this yet. I'm going to move this over to the... Okay, so your variables are on the left side when you start. You're going to move them over to the right side under... They start on the left and then they move over to the right. When they're on the right, they're ready to be analyzed, but we got to select some settings here first. So first of all, display frequency tables should already be selected by default. But other things we need to choose. So we'll go to charts over here. I think the default is none, but you're going to go to histogram, select histogram, click continue. We don't need to show the normal curve necessarily for now. Select the histogram. It's going to give you 2 histograms, which is cool. And then select statistics, and I'm going to select mean, standard deviation, skewness, and kurtosis. Those are my choices for now. Skewness and kurtosis are going to be key to us understanding if these data are ready to be analyzed. So, and I click continue, click OK. We're going to get a bunch of stuff. Okay, so that first chart is your statistics, and you see the mean for the first variable, 4.47, mean for the second one, 2.39. They're on different scales, so if we were to compare them directly, we would need to calculate z-scores for each one. I won't take you through that here, but we could do it because we have the means and standard deviations for each one now. Skewness and kurtosis values I'll come back to in a minute, so we need to do a quick calculation here. But let me show you what else is presented. The frequency distribution or frequency table is here. In particular, the first 2 columns are the key information where it's listed out like 1 through 9 here. Those are the actual values for fitness. And then the frequency of them. So for example, for the first row here, there's 2 ones. 2 people said 1. Scale of 1 to 10. How fit are you? 1. That's kind of sad. Only 1 person said 9. Nobody said 10. Nobody said 8. People have high standards, I guess. So it's a count of how many people said gave each response. Same thing for the relaxation variable here. Pretty even spread. You can see the description there of each one, 1 through 4. So not at all unable to relax. 6 people said that. So that's a good thing for them. The severe one, it bothered me a lot. 4 people said that. Okay. So those are just the counts, and then those are translated to histograms. Now, SPSS will make the histograms automatically. It's not going to give you choices regarding like how this looks, at least not up front, regarding colors and if they're, sometimes what a histogram will do is it'll group values together. So I might group 0 to 1 and then 2 to 3, create these intervals, and then make bars based on that. Here it's just graphing each individual value by itself. So the high point there for fitness is at 5. 5 people said 5 right in the middle. And then for the relaxation variable, there's a pretty even spread 1 through 4 here. So the bars going up represent, like, the taller it is, the more people said it, more people gave that response, and so on. So let's go back to the skewness and kurtosis real quick. Okay, so looking at the, back at the statistics here, the first box that we got, you see skewness, for example, for the fitness variable is 0.149. It's positive, but it's very close to 0. And the standard error of skewness is 0.524. So what we need to do is divide 0.149 divided by 0.524. Once we get a number for that, we can just make a decision. So if that value, if that resulting value is greater than 3 or less than -3, we have a problem. That value is significantly skewed to one side or the other. I'll give you a hint. In this example, it's not greater than 3. And then we do that 4 times if we have 2 variables. So for the first variable, you do it skewness divided by standard error of skewness. Then you do kurtosis, which in this case for fitness is -0.340, divided by standard error of kurtosis, 1.014. Make that division, that's the second one. And then since we have a second variable, we do this again for the unable to relax variable. So you go skewness 0.063 divided by 0.536, standard error. Then you go for kurtosis for the second one, -1.556 divided by 1.038. So 4 divisions. If any of those values are greater than 3, then we have a situation where we need to follow up. Greater than 3, less than -3. Follow up. And then at that point, we need to check for outliers. And you might want to go back at that point to the notes on outlier checks and this sort of thing. I'll give you a hint that how to deal with outliers. The rule of thumb is in those notes. But in this case, for this particular example, I did those 4 divisions. None of the values came out greater than 3 or less than -3. So we were okay. If they did, you go back, you check for outliers, and you proceed with some decision making. There is one area of concern here, however, and that is that second variable, the relax variable, there was one person who didn't fill out the survey. That person has missing data. Let's figure out what to do there. All right, so we've got a person with a missing value in our data set. We've got 19 total people, and one person on one variable is missing a value. Okay. So what do we do? Well, first of all, we try to figure out if it's more than 5% missing. In this case, we have that one person out of 19 total people, 1 out of 19. If you divide 1 divided by 19, you're going to get more than 5%. It's a little bit more than 5%, just barely. If you didn't get 5%, if it was less than that, you can probably just kick that person out of the data set. They call that list-wise deletion. Just get rid of that person. It's not a big deal because it's not a big portion of your data. But in this case, we should follow up. And so we're going to follow up by going to Analyze. And we're going to try to see through a missing value analysis in SPSS. Sounds very intense, but it's really just pretty quick here. See if this is a problem. See if the data is missing randomly or not. So we're going to move both of our values over to the right. We're going to select EM. And what this is going to do is we're going to see if this is missing randomly. And including that first column, is it missing randomly based on their fitness as well, not just their ability to relax. So probably good to move both over, actually. Or however many variables you have should probably be moved over. All right, so we're going to select EM, and we're going to see what happens. We're going to hit OK, and we're going to get some stuff that we don't need. What do we need? We need the results here of Little's MCAR test. It comes, I don't know, kind of snuck in there at the bottom of this table. Little's MCAR test says sig equals 0.803, so that's the value we need. 0.803 is greater than 0.05, suggesting that, yes, this value is missing at random. We're okay. So we can kind of do whatever we want. If it was less than 0.05, this value was less than 0.05, then the value would not be missing at random completely. And we would want to see why, like what's going on. Is it related to their fitness level or something else? This is more likely maybe in a data set with more columns of data. Anyway, so it says sig equals 0.803 greater than 0.05. That's the criteria for saying, yes, this value is missing at random. And so you can kind of justify doing as you wish here with this value. And for this particular data set, and if we're working with a small data set in a homework, let's say, and we don't have a lot of information about the people, other considerations, just go ahead and do list-wise deletion. So that's what I'm going to do. I'm going to go back to the data and delete this person across. This is person number 17 who answered 5 on fitness and nothing to the anxiety or the relaxation item. So I'm going to just clear that person. Pow! Gone from the data set. Now we have 18 people instead of 19. We can rerun the whole thing. In fact, you probably would do that if you're working through homework. Rerun all of the descriptive statistics at this point. Get them over again. Recheck the skewness and kurtosis real quick. They're probably going to be fine in this case. I'm telling you, in this example, they're fine. So I'm not going to show it to you again. So get those descriptive statistics again. If this were a real report, you would then report those after you've list-wise deleted person number 17. That would be your official report of descriptive statistics, would come from here. And then there's just one more thing to do at that point, and that is compare variances across the two groups. So I'll show you that real quick. All right, so the other thing to check here is just the variance of column 1 against the variance of column 2. So I went ahead and make sure you include variance when you rerun statistics or when you get the descriptive statistics after you've made any changes that you might have made to your data set, deleting the participant that had the missing data. Whatever you do, when you rerun everything, make sure that you grab the variance. Well, you could also just grab the standard deviation and square it, but it's easier to get the variance. So I'm showing you the results here for this particular example. Once I reran it with the 18 people, the variance for the fitness variable there was 4.967. The variance for the relaxation variable, 1.428. So what you do is you divide 4.967 by 1.428, and you get the result. If it's greater than 10, which it's not here. Okay, we're good. If it's greater than 10, then you got to stop. You can't compare these two variables to each other in a test, typically, because they're too different in variance. One is high variance, the other is low. Can't do it. Can't really compare them after that. They're weird with each other. The result here, however, is that the fitness variable variance is a little bit greater than the other one, but it's not greater by a factor of 10. So we're okay. We can compare them to each other. And that's the last step. Now enjoy your data.